All right, let's dive in. Today we're going to untangle three huge ideas that are pretty much running the world right now: data, learning, and optimization. We're going to see how they all fit together. You know, how we go from just a mountain of raw information to making really smart decisions.
And really, it all boils down to this one massive question. I mean, think about it. We are absolutely drowning in data, right? Everything from sales numbers to what's trending online. But the real trick is, how do you actually use all that stuff to make better choices? Well, the answer starts with our first big concept.
And that's where data analysis comes in. It's the whole science, really, of turning all that raw data into insights you can actually do something with. It's so much more than just staring at a spreadsheet, you know? It's a step-by-step process for finding the real story that's hiding inside all that noise, and then using that story to figure out what to do next. Okay, so how does this whole thing actually work? I promise you, it's not magic. It's more like a blueprint, a really methodical way to get from a vague question to a seriously powerful answer. And here it is, the whole process laid out in 6 basic steps. First, you've got to figure out what question you're even trying to answer. Then you go out and collect the data. And then comes step 3, and honestly, this might be the most important part of the whole shebang. You have to clean the data. Seriously, there's a saying in this world: garbage in, garbage out. If your data's a mess, your results will be a mess. Doesn't matter how fancy your tools are. Only after all that do you get to analyze, visualize, and finally act on what you found. It's a really clear path from "I have no idea" to "okay, let's do this." Okay, but here's the thing. Not all data analysis is the same, not by a long shot. Depending on the kind of question you're asking, you're going to get a very different type of answer. And this is where it gets really cool, because this is where we shift from just looking backward to actually trying to shape what happens next.
This table lays it out perfectly. You've got 4 types. First, descriptive analysis. That's just what happened. Think of your basic monthly sales report. Easy enough. Then you've got diagnostic, which asks, okay, why did that happen? But let's be real. The real magic is in the next 2. Predictive analysis tries to tell you what's gonna happen next. And the holy grail, prescriptive analysis, goes even further. It tells you, okay, so what should we do about it? This is where we go from being reactive to being proactive. It's a total game changer.
So, how on earth do we make those incredible jumps? How do we predict the future and get advice on what to do? Well, the answer is a technology that has absolutely turned the world on its head: machine learning.
So, what is machine learning, or ML? You know, at its core, it's just a way to teach computers by showing them examples. Think about it. Instead of a programmer sitting down and writing a million if-then rules for every possible scenario, you feed the machine a ton of data and let it figure out the patterns for itself. It basically learns from experience, kind of like how we do, but on a massive scale.
And ML isn't just one thing. It comes in a few main flavors. You've got supervised learning, where you give it the answers, like showing it 1,000 pictures of cats and telling it these are all cats. Then there's unsupervised learning, where you give it a bunch of data and just say, find something interesting in here, like grouping customers together. And finally, you have reinforcement learning, which is all about trial and error, like an AI learning to master a video game by getting rewards for good moves.
But let's pause for a second. What does it actually mean for a machine to learn? I mean, how does it go from just looking at raw data to making a scarily accurate prediction? To really get that, we need to make a super important distinction between the goal and the actual process it uses to get there.
And this is that distinction. It's super important. Think of it like this. Machine learning is the what. It's the goal. We want to build a model that can make great predictions. But optimization, that's the how. That's the engine under the hood. It's the actual process of tweaking and refining and tuning that model over and over until it's the absolute best version it can be.
All right, so let's pop the hood and take a look inside that engine. How does a machine actually find the right answer in a sea of wrong ones?
This is one of my favorite ways to think about it. Just imagine a massive, sprawling landscape full of hills and deep valleys. Now, every single spot on that landscape represents one possible version of your model. And the height of the land at that spot, that's how much error the model has. Basically, how wrong its predictions are. So your goal is really, really simple. Find the absolute lowest point. Get to the bottom of the deepest valley, because that's where your model is the most accurate.
So how do you find that lowest point when you can't see the whole map? Well, you do it through this simple learning loop. It's often powered by an algorithm called gradient descent. Here's how it works. The model makes a guess. It then checks how wrong it was. Then, and this is the clever part, it figures out which way is downhill from where it's standing. That downhill direction is the gradient. It's just the steepest path down. So it takes a tiny step in that direction, and then it just does it again, and again, and again. Thousands, maybe millions of times, just constantly taking one little step downhill, until it can't go down any further and finds itself at the bottom.
So if you remember one thing, let it be this. Machine learning is the whole field, the big idea. But optimization, that's the engine that makes it all go. It's the workhorse at the very core of the learning process, always trying to reduce that error. They're two sides of the same coin. You just can't have one without the other.
So, there you have it. We've gone all the way from just a chaotic pile of raw data to building a blueprint for making sense of it, all the way down to the inner workings of the engine that lets a machine learn. We've seen how noise becomes knowledge. So the big question left for all of us is, now that we've peeked inside this incredible engine, what are the truly great problems we're all going to solve with it?